students, welcome to Shruti Academy. A very happy new year to all my students. Okay, so let us start with the topic refraction at spherical convex surface of class 12 of chapter 9 ray optics and optical instruments. So we are going to study in this session about the refraction at spherical convex surface. So we already know what is refraction. Refraction is the phenomena of bending of light when it travels from one medium to another medium. Okay, so it depends on what basis it is traveling, from rarer medium to denser medium, or from denser medium to rarer medium. So when it travels from rarer medium to denser medium, it bends towards the normal, and when it travels from the denser medium to the rarer medium, it bends away from the normal. Okay. So the refraction we need to study for the spherical convex surface. So we already know what is convex surface and concave surface. This is the convex surface shown over here. We already know these all terminologies: the pole, the center of curvature. This is the position or the source position, or we can say the object position from where the light is being entering. So the light is being entering from the medium having a refractive index mu1 to the refractive index mu2, to the refractive index to the medium which is having the refractive index mu2. Okay, and over here we can see the normal is being drawn over here. Okay, so the light, when it is traveling from rarer medium to denser medium, mu1 is supposed to be rarer medium, so it is traveling from rarer to denser medium. So we will be writing this point: it is traveling from rarer to denser. It is traveling from rarer to denser medium. So what is happening? It is bending towards the normal. So we can easily see over here, my ray of light, it traveled from here at the normal, and when it entered the another medium, it bended towards the normal. So this is the angle of incidence. We already know the angle between the normal and the incident ray is said to be the angle of incidence. So this is the angle of incidence, and this is the angle of refraction. This is the angle of refraction. So after getting refracted, the angle between the refracted ray and the normal is said to be the angle of refraction. Okay, so this is the angle of refraction. So we will be using here the Snell's law, and with the help of Snell's law we will be proving the refraction at the spherical convex surface. Okay, so let us apply the Snell's law. So using Snell's law, it is clear that mu2 upon mu1 is equal to sine I upon sine R. Okay, so we can cross multiply it. So we will be getting mu1 sine I is equal to mu2 sine R. Okay, so mu1 sine I is equal to mu2 sine R. So we are getting over here. Okay, so we see over here that a triangle is being formed over here. Okay, this is center of curvature, this is object, and this is the normal. So if we take the triangle NOC, we find one triangle this, and the other triangle which we can find over here is NCI. This is the image, this is center of curvature, and this is the normal. So first we will be taking the triangle NOC. So taking triangle NOC. So when we will be taking the triangle NOC, we can easily see this is the I is the exterior angle, and the exterior angle is always equal to the sum of opposite interior angles. So alpha plus gamma will be equal to I. So taking triangle NOC, from here we will be getting I is equal to alpha plus gamma. Okay, and when we will be taking the triangle And when we will be taking the triangle NCI, so there also we will be applying the same concept. The exterior angle will be equal to the sum of opposite interior angles. So there also we can see, so taking triangle NCI, so there also we will be getting gamma is equal to R plus beta. These alpha, gamma, beta, I have just taken the angles. You can take any of the denominations of your choice. Okay. So gamma is equal to R plus beta. So R will be equal to, angle of refraction will be equal to gamma minus beta. Will be equal to gamma minus beta. Okay. So from here we find over here, if we see this equation, we find over here that sine I and sine R are very much small. They are very much small. So they can be near, sine I can be nearly be equal to I. Okay, we can take nearly be equal to I. Because it is very small, the value comes out to be very small. Also sine R is also very small. So since sine I is very much small, so sine I can be taken as equal to I. Okay. So this is for the sine. Similarly, we can write for the sine R. We can write for the sine R. Okay. So here we will be writing for the sine R. Sine R is also very small. So sine R can be nearly be taken to be equal to R. Okay. Okay. So from here we'll be getting mu1 I to be equal to mu2 R. Okay. And in the place of I, we can put the value alpha plus gamma, which we have found out with the help of triangle NOC. So it becomes mu1 alpha plus gamma is equal to mu2. In the place of R, we will be putting the value of R, which we found out from the triangle NCI, gamma minus beta. So it will be gamma minus beta. Okay, it will be gamma minus beta. Now we will be finding out the values of alpha, beta and gamma with the concept of angle equals to arc upon radius. So alpha, beta and gamma, we will be finding out the values with the help of the concept angle is equal to arc upon radius. Okay, so we see that for alpha the arc will be NP and the radius is the distance from the arc, that will be PO. Okay, so my alpha will be equal to NP upon PO. Okay, then beta. Then for the beta is angle over here. So the arc will be again NP and my distance of the radius will be PI. Okay, so NP upon PI. Okay, then gamma. For gamma, it is clear. Gamma will be equal to NP upon PC. Okay, so it will be NP upon PC. So it will be equal to NP upon PC. So we have got these values. These all values of alpha, beta and gamma we will be putting in this equation. Okay, so first let us solve it. So from here we are getting mu1 alpha plus mu1 gamma equal to mu2 gamma minus mu2 beta. Okay. So in the place of alpha, I'll be putting NP upon PO plus mu1. In the place of gamma, NP upon PC is equal to mu2. Gamma is again NP upon PC. Okay, and mu2 minus mu2 beta is NP upon Pi. Okay, so we got these values over here now. So NP, if we take common from LHS and RHS, it will get cancelled. So we can easily cancel the NP value. Okay, so we are left over here with mu1 upon PO, mu1 upon PO plus mu1 upon PC is equal to mu2 upon PC minus mu2 upon Pi. Mu2 is the refractive index of the denser medium, mu1 is the refractive index of the rarer medium. Okay, so this equation we have got. Now what is PO, PC and Pi? We have to replace these also. Okay, so PO is the distance of the object. It is the distance of the object and it is given by u. But here we have to take minus u, because according to the Cartesian system, which is the same as the geometrical Cartesian system, so all the values lying at the left hand side will be taken as negative, and all the values lying at the right hand side will be taken as positive. So my PO will be minus u. Okay, so I'll be substituting mu1 upon minus u. So let us write down PO to be equal to minus u. Then what is PC? PC is the radius of curvature R. And it will be taken as positive because it is on the right hand side. Okay, it is on the right hand side. Then Pi will be equal to V. Pi will be equal to V. It is also positive because it is on the right hand side. Okay, so all the values lying on the right hand side of the surface, the refracting surface, are taken as positive, and all the values which are lying on the left hand side of the refractive surface are taken as negative. So it will be plus V itself. So PO is minus U, not mu U, it is U. Then PC is equal to R and Pi is equal to V. So let us put all the values in our equation. Okay, so from here we are getting plus mu1 upon R to be equal to mu2 upon R. Okay, and minus mu2 upon V. So we can take the terms of R on one side and take the rest of the terms on another side. Okay, so I am taking this V on that side. Okay, so I'll be getting over here mu2. It will become positive when this mu2 upon V will go that side on the LHS. So I'll be getting over here mu2 upon V minus mu1 upon U to be equal to mu2 minus mu1 upon R. So this is the value for the refraction at the spherical convex surface. So this can be used in the numericals part of view. This can be applied in the numericals part of view. This can be easily applied in the numericals. So the expression we have got is mu2 upon V minus mu1 upon U. Mu2 is the refractive index of the denser medium. Mu1 is the refractive index of the rarer medium. V is the distance of object and U is the distance of the, V is the distance of the image and U is the distance of the object, is equals to mu2 minus mu1 upon R. So this is our expression. Okay. So in this manner you need to derive, you need to understand and then apply in the questions. Okay. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.